This lecture is based on the factors that affect or is cause of the London dispersion force. Before starting the lecture, let's have a look at what is London dispersion force. So as you all know that in London dispersion force we do have two non-polar atoms which are attracted towards each other, in which one atom becomes an induced atom. It forms like this by the repulsion of the negative form, like here negative electrons are present. Because of the repulsion, these negative atoms in the surrounding are repelled and they goes at the end and form a cloud. Apart from that, here positive charge appears. When these positive charge attracts these positive and negative charge, they come closer. In this form, the electronegative cloud attracts towards the positive nucleus of another atom that is induced and form a quark. A quark, there is a point that it is not constant, it is quark or instant cloud. It does not last for more time, but it is just because of the pressure. So we do have a quark cloud of electrons, but due to repulsion and some more factors, it do not last, and we term it as an instant induced atom, and this one is called induced. Like it is permanently induced, as in the other forces like ion dipole this happens, and dipole induced this happens. So it is the induced just like in the dipole induced one, but this is an informal way. Let's have a look on the factors. So there are basic two factors, size and number of atoms. But somehow polarizability also affects the London dispersion force. That's why I have written this. First of all, let's have a look on the size. So basically, size doesn't matter a lot. Just suppose two atoms, one of this size and one of this size. Now tell me, in which one there would be more nuclear force? Of course, in this electron there would be no more nuclear force. Why? Because it has a smaller size. Apart from that, this nucleus has more size. It has more shells as well as its nuclear force. Nuclear force and binding force is weak. Now, if we talk about the polarizability in terms of that, so if there are more electrons in the shell, so there would be more bigger cloud of the electron, and that is beneficial for the molecule. That's why size does matter. After that, we have second factor, polarizability. To understand polarizability, let me tell you by showing a picture. Have a look at this. Now here you can see two atoms of non-polar two molecule helium atoms. Now what about the polarizability here? There would be less amount of the polarizability. Why? Because there are less electrons. Basically, the polarizability is the tendency of electrons cloud to distort in this way. That means, just suppose that there are two electrons. They attract these two electrons. That is being shown here. When these two electrons are attracted towards the nucleus, so these electrons are repelled. Now this is in form of a London dispersion force that is also known, that is also resemblance with dipole-induced. Now here the polarizability matters. The polarizability means the tendency of making this cloud of electrons. Now here another word, distortion, is being used. Distortion. Now the word here distortion basically means deformation. When an atom deforms, that means there is an performance of the distortions. So polarizability is basically the ability to deform. So we can take polarizability with the resemblance of the size. So here polarizability is directly proportional to the size. The bigger the size, the larger the polarizability. Why? Because there would be more electrons cloud. Okay, now let's have a look on the last factor. Numbers of atoms. Now you get all these. I don't think so. We need to work at it at a long or at a high level. Why? Because we know that basically if the number of atoms in an molecule are larger, just suppose that we do have CH4, methane, and then we do have another CaCO3. Now basically these are not non-polar, but just for an example. Now just suppose that, not suppose, have a look that which one is larger sized. Of course, CaCO3 is of larger size because there are more electrons. There are more molecules, there are more number of atoms present in it. That's the thing. Now here in the CaCO3, there would be more polarizability because there are more number of electrons. Leave this. Let's have a look on a polar one. Just suppose that we do have O2 and then, okay, leave this. This is nothing. O2 and then H2. Now tell me, which one is more polar? There is more polarizability in the O2. Why? Because it has larger number of electrons. That's why there is more polarizability. Now here another thing. Polarizability is also directly proportional to the number of atoms. Now let me tell you a bonus point that directly proportional to the polarizability, and polarizability is directly proportional to the number of electrons. But here one thing is inversely proportional, and that one thing is nuclear force. If there would be more nuclear force, so of course there would be less electron cloud, and that's not good for the London dispersion force. And that was all about today's lecture. Thank you. I hope you enjoyed.